I've been here for about 7 months now. In fact, my 7-month birthday is tomorrow, so I'm really looking forward to that. Previously, I was at Expedia, Betfair, and a bunch of mostly failed startups.
And I'm Shri. I'm the resident astronaut at BuzzFeed. While we're still trying to figure out our space program, I do moonlight with the infrastructure team. I did found this hashtag. It's live on Instagram. Everything's better after ice cream. I'm also lactose intolerant. And I take photos without filters. There are no filters on it.
So who is BuzzFeed? Well, we're a fast-paced global news media company. We have over 9 billion content views per month, and we have lots and lots of brands. Our biggest three, in my mind anyway, are BuzzFeed, which is the listicles and the things that we've made popular since 2006. News, which is where we do investigations and cover world events. And Tasty, which is the biggest phenomenon that I've ever seen, and seems to be all over my Facebook feed. We have native content published to Facebook, YouTube, Snapchat, as well as our owned and operated sites, as well as having mobile apps on iOS and Android.
So, BuzzFeed and AWS. We started out being hosted at this data center down in Lower Manhattan on Wall Street, and Hurricane Sandy came by and flooded just about every street in that area. So overnight, we had to move our infrastructure to a different provider, and we looked around. Amazon was kind of logical. We took the stuff, went there. So that's our first date, October 29th. Hurricane Sandy was the perfect venue, and at this point, we're more or less committed.
So talking about how our tech at BuzzFeed, we started out in 2006 with a simple web app. And over time, over 10 years of development, this became a large monolithic application. And change sets were huge, and we had to have choreographing heroes for release managers. By that, I mean releases would take all day to go through, and if you had to do rollbacks, it would mean an all-nighter as well.
So, enter microservices. That's the buzzword everybody's talking about, right? What does that actually mean? So we basically took our large monolithic app and broke it down into functional little bits and pieces. Functional meaning each thing serves a specific function, and we tried to keep the code base as small as possible so whoever is maintaining it or testing it actually knows what's going on. Some of the examples, the popular ones are, we have something called SiteRouter, which basically is the front line of everything that hits the BuzzFeed infrastructure. And it looks at the request and says, this is an API request, send it there. This is a request for an image, send it there. This is a request for blah, 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 send it there. BPager is another service we have, which is a microservice. Basically takes care of rendering every single article that you see on BuzzFeed. So when you go to buzzfeed.com/10 things I did when I was 10 years old, that's BPager doing its job after SiteRouter sent the request to BPager. Apart from that, we have 230 other services in production, which are all microservices. So that kind of leads into the next thing, which is Docker, and Andrew's going to get into what Docker is.
I imagine most people here are familiar with Docker already. It's a containerization framework for Linux. It enables you to package up any application and to deploy it, manage it, and build it all in the same way. I got that the wrong way around. It's build, manage, and deploy. Anyway, from that perspective, it means no matter if we have a Golang application, a Python application, a Java application, or whichever, we can deploy them all using the same tools and do so in a consistent way, and rollbacks become easy as well.
So fun little fact, not sure if you know it, but the whole Docker concept comes from these shipping containers, which were standardized a couple of decades ago so that ships don't have to handle different sizes of containers. And so Docker kind of pulls off the same thing. So ECS is at the center of our master plan. Of course, AWS builds everything elastic, right? In this case, ECS is basically a container store which lets us define tasks and run the tasks accordingly. So each little Docker application that the developer builds is pushed over to ECS, and ECS runs multiple instances of it. So what is ECS? So you define the task, you run the task, it gives you orchestration, it gives you deployments. In Amazon's own words, it's a highly scalable, high-performance container management service that supports Docker, and it lets you easily run applications on top of Amazon EC2 instances. We cannot go further without introducing the elephant in the room.
Last year, during a hack week, we built a tool which we call Rig. This is a platform as a service, with an opinionated platform as a service, built on top of ECS, which we use to enable us to deploy and manage our applications, and to do so in a fun way. So what is RIG? Well, the definition according to Google, or probably Merriam-Webster, is a setup as an equipment, device, or structure which is typically deployed in a hastily or makeshift fashion. In many ways, this is Docker for developers. It's a framework which is held together with bits of Python, involving Docker, Jenkins, Nagios, and a whole host of Amazon plumbing, ECS, IAM, Route 53, RDS, and a whole lot more.
So what we call RIG internally as this platform, it's basically a platform as a service. It's nothing great by itself. It's the glue that brings in all these amazing things into one and lets our developers go from their laptop to the internet. So in short, it's magic. It was a huge game changer. Like I said, it was the glue that held everything together and let our developers move at the speed of light. As some of you may or may not know, in the old world with monolithic apps, you had the developers write the code, and then you go to this ops guy who, might be me, and then you tell him, hey, I have this thing I need to deploy, and there's all this back and forth, which probably wasn't the most efficient thing. So RIG was a complete game changer for us. So we're going to get into a couple things, 8 to be precise, in true BuzzFeed style. 8 things we learned along the way. Is that a British spelling for you? Learned?
Yes, sorry, it's Britishism. One thing we'd say is we would like to say it's all been smooth sailing, but to be fully open and honest, there have been a few bumps along the way, and yeah, we would like to share what we've learned.
Config management, something we all have come to love and hate at the same time. It's incredibly useful. It helps you replicate things over and over again. But most of them use custom directives, and that's hard because developers are already programming in the language of their choice, which is Python, Go, C, C#, whatever it is, and they don't really want to learn another directive-based config management tool. Bash and YAML is something we all love. Everybody knows some Bash. And we wanted to keep it such that we could move fast, and config management at one point was slowing us down. And there's always this constant struggle of who owns it. Like, does ops do config management or does dev do config management? That's something we never figured out. And who keeps it up to date? What about environmental differences? Basically, we wanted to allow people to do what they wanted to do in a really, really, really quick way. So guess what? Config management is hard, doesn't work, and in true Docker style, if you have ever used Docker, it's basically just Bash, right? It may work in some places, but the overhead was just too much for us, and we needed to figure out a faster way to do it. And Docker came to our rescue.
Obviously, Docker containers by essence are immutable. So our services became immutable, which is great, because it means if we wanted to redeploy an application, it was a one-click operation. But we also extended that to the hosts running the ECS agent, the hosts running the Docker containers as well. And this gives us a whole bunch of benefits. For example, what an autoscaling group does is it will make sure that if a node fails, it'll be automatically replaced. Last week, I was at dinner with my next-door neighbors, and they're in their 50s, and they're not really in tech. He's a banker, she works in health. And so we're chatting away, and my phone rang during dinner, and I was primary on call. I answered the phone. It was PagerDuty, saying, PagerDuty alert, press 4 to acknowledge. So I acknowledged it straight away, just to shut the thing up. Having done that, I then looked on Slack, checked in one of our channels, and I noticed an alert saying something about some warning, and then a couple of minutes later, there was a notification saying it had recovered. Phil, the next door neighbor, he turned to me and said, what the hell just happened? So I explained to him, well, a robot just phoned me up and told me that something was broken. But it's okay, because another robot fixed it automatically for me, and everything has self-healed automatically. It kind of felt that at that moment I was living in the future. So immutable instances are great because they mean that an autoscaling group can fix something when it breaks, provided you have the metrics set up correctly. But there are a few pains with that as well. The first one being that if you want to add a new package to the base image, for example, you want to debug something, suddenly you have to rebuild the whole system. And whilst we can do that in a relatively short period of time, it's a bit more hassle than maybe it used to be in the old world. More pertinently, and something which probably happens for us more often, is BuzzFeed is growing. And every time a new person joins the infrastructure team, we need to add their SSH keys to the hosts. And this is pretty painful. So we're in the process of moving to certificate authorities for SSH. And Netflix have open sourced a tool called Bliss, Lyft have built upon it, and that's something we'll be moving to in the next few weeks or months to fix that. When we started down with the rig world, we set up a new Amazon account just for rig, and we set up a separate VPC for dev, for stage, and for prod. This all seemed good, because we'd have good separation from a security perspective. This should be great. And it was. From a security perspective, it was completely great. But API rate limits are shared between all VPCs on an account, which means if you add a bunch of load balancers into dev, and they're all hitting the APIs to describe instance health, suddenly you may find you've hit that rate limit for that service call, and you've just broken production. So basically, the way to fix this is to separate out into multiple AWS accounts. One AWS account for dev, one for stage, one for production.
Multiple accounts are hard. Terrible analogy, Tim. I'm really good at terrible analogies. It's kind of like owning two cars, putting the keys of one car in the other, and then putting the other key into the other car's trunk, and then claiming you have security. It is secure. It's absolutely secure. But it's hard. So when you have multiple accounts, the things you run into are you don't share anything. If you build an image here, guess what? You don't get it there. You need to redo the work. And then there's no way to go from, let's say, for example, if we were split between stage and prod in two different accounts, there's no way to build an image in stage and say, this works, and let's push it to production. Just can't happen. Luckily, our friends at Amazon are working on things to get cross-account, ECR, which is basically our Docker container registry, so we don't have to build the same Docker image all over again in the other place. We recently moved, so for a long time we had something called a test cluster, which was supposed to be test, but at some point people started using it and had the expectation of, oh, this is not test, this is like serious, we don't want stuff broken here. So we actually built something called an unstable cluster. That way no one can argue with us what that means. So we built the unstable cluster into its own account, and we're kind of, feeling the pain right now a little bit in terms of, going across accounts, but our friends at Amazon have promised us, better connectivity between separate accounts. Smaller, more frequent autonomous deploys. Like I mentioned in the beginning, microservices let us leverage the fact that each service was absolutely focused on one job and one job only. That way the developer who owned it or any other developer who wanted to make changes went in, did not see a million lines of code, and probably saw like a couple of hundred lines, which is more in tune with what a person can digest at one sitting. So the change sets are much smaller. It's quicker pushes. You don't have to wait for that weekly deploy to push your change out. If you want to make that small change that makes something slightly better, guess what? You can make a one-line change and push it out into production right away. We also support canary deploys, which basically lets you test out changes. So if you have 5 instances of a certain app running in production, you can push out one instance with the new code. So it's getting traffic, but it's only one instance while the other 4 are still doing the old work. That way you can benchmark performance, and if something goes wrong, you can quickly back out of it. Fixes are easier because in the old world, and I always joke about this because I love wearing that superhero cape. I mean, I'm an ops guy. I love situations where it's like, yeah, I got this, don't worry, I'll fix it. But in the past, whenever we had an outage of any sort, I would go in, SSH into instances. I know Raymond is somewhere here who's my coworker. He loves doing that too. SSH into instances, change lines of code in real time, and then take off our cape. We didn't need to do that anymore. With microservices, guess what? You can just make that change, push it, and push out that Docker image via canary deploys, and you have a more predictable way to get to the state you want to go to.
Building on top of that, I mean, it's one thing building a system that makes the ops guys happy, but with Rig, we really focused very heavily on the dev workflow. And we have we work from the basis of having a mono repo, which means that all our 230, 240 services, they're all in one repo, which means if you want to look up how a different application works, you can do so. If you want to share code, hey, that's easy. And if you wanted to discover what all the applications are at BuzzFeed, hey, they're all in one place. So that's pretty great. On top of that, as part of an opinionated system, there is only one way to deploy. As Sri was just saying, it's the same process whether you're deploying a hotfix, you're adding a feature, you're fixing some typo, or it's a complete from the ground up refactor. The other thing, which I was chatting to someone before the talk started, and I'm not quite sure if he believed me, but deploying applications at BuzzFeed is now enjoyable. We do it so often, it's fun. We do it over 250 deploys per day, and in the last 12 months, we pushed over 30,000 deploys in BuzzFeed, which, if you remember back in the old world, we were doing, one deploy would take us the whole day, and would take multiple people the whole day. To be doing it 250 times per day, and it not to be actually taking up people's time when it's happening is a complete, as Sri mentioned earlier, a complete game changer. For example, we had a service outage recently, and the team who worked on it were based in Europe. And the outage was late afternoon in New York, and the team who would normally respond to it and fix it, they were sleeping. So rather than trying to wake someone up and disturbing their night, it was possible and even straightforward, because of our standardization, to have someone who'd never worked with the code base before to patch and push out a fix really quickly. So we're definitely reaping the benefits from standardization. But as Sri was saying, not everything is in rig yet.
Cost benefits. There's this Google engineer called Kelsey Hightower who always uses Tetris to kind of illustrate this point. I'm pretty sure you have seen some of his talks. If you haven't, you should look him up. There's a huge cost benefit from increased density because while we were still a monolithic app, whenever we had services, our mind was in the right place, and we tried to separate out as much as possible. So every single service that was written went on dedicated EC2 machines. And every service needed at least 2 machines because, for redundancy, if not more. So if you actually do the math, we have about 230 microservices, and if each service was put on its own machine, we'd be running about 600, my math is weak, 600 something instances. In contrast, I think in production across the board, we run about 30 instances. So the cost saving is huge because when you dedicate an EC2 instance or any other, pizza box instance or whatever you want to call it to an application, there's a lot of CPU and memory overhead which you give the app in order to burst, which is essentially going to waste. So we basically what ECS and Docker let us to do is compact it into a smaller number of instances so that they all share the same amount of burst headroom. Moving to ECS definitely increased density. Devs are allowed to specify memory and CPU requirements. So if you go into your app, you can say I want about 512 megabytes of RAM and about 1/8 of a core of a CPU or maybe a whole core of a CPU. And we work with dev to determine those numbers. For context, like I said, 240 services. We would have had about 500 instances running to have those in production, but we only actually do about 30.
So from an infrastructure perspective, it's really easy. When we build applications, we dual push to multiple ECR repos, one East Coast, one West Coast. And outside of that, from an infrastructure perspective, it just works. We use a bit of Terraform to deploy the basis of rig, and from there, it will kind of build itself up from there. Unfortunately, not everything is quite as easy as it is from the infrastructure perspective. And from an application perspective, it's a little bit harder.
But we have databases. Our DBA actually was annoyed with this slide. He was like, why you gotta be negative about databases? While our applications are nice and compact and easy to move around, we can literally take our images and go to the US West or EU West or Africa or Asia or wherever you want to, right? They're just Docker images. They can go anywhere. The data that we hold is harder to take with us. It's not the database itself that's the problem, but it's probably the way we approached our application development in each app wants one source of truth and cannot deal with more than one source of truth. It is something that we are actively working on. Also, we use RDS pretty heavily to host our MySQL databases, and RDS doesn't quite out of the box yet support cross-region and cross-continent replication. But I'm pretty sure that'll happen soon. So the apps we focused on to go multi-region are usually stateless apps that don't have a database back or deal with assets in S3 or on the CDN level. ELBs, they're a blessing and a curse. So you probably wondered, how do we serve multiple apps out of the same instances and run multiple instances of the same app as well? ELBs are a godsend in that way. If you haven't heard about ELBs, they're Amazon's elastic load balancing service. Everything's elastic at Amazon. And they scale to the number of instances you have. So they are amazing in that I can have an ELB and I can have the backends going anywhere, right? In theory, anywhere. But we hit a limit because the port numbers needed to be unique for each application. So, and ELBs can only go to one port number. So anytime we wanted, let's say I mentioned we were running about 30 instances, 30 physical instances in production. If someone needed to deploy an app with 31 running containers, guess what? It's not possible because you can only spread out the 30 over the 30 physical boxes that you have. It was a problem. We never hit the problem per se. We've never had to run n number of instances of a certain app, but we were actively looking for a solution.
Last year, Amazon announced their version 2 load balancers, the application load balancers, or ALBs. And this seemed to be a pretty good way to go because now they support routing, and on top of that, because they were designed with ECS in mind, they supported having multiple ports for a single application. And for regular EC2 services, Amazon wrote a script to make the migration easy. It was basically trivial. Unfortunately for ECS, this was somewhat more painful. A task definition only supports being registered to a single load balancer at the same time. So if you don't mind taking downtime, hey, you can just change the definition. But to do it seamlessly, it required a bit of a sleight of hand. You had to, in our case, we ended up standing up a migration service with the ALB attached. We flipped the load to that. We removed the original. We reprovisioned the original with an ALB, flipped the load back, and then deleted the migration service. So it was fine, but it felt like a little bit clunky. And it's something which hopefully will get better in time.
So deploy with haste is our motto at BuzzFeed ever since Rig came out. Everybody looks at Rig as this repository with a bunch of Python code and Amazon constructs that no one understands. But actually, it is a culture change. We want you to ship fast, break fast, and most importantly, fix fast. And it also allows us to enforce from an operational standpoint methodologies and stacks that we are okay with and we like, and we just give it to the developers and we stay hands off. I have personally never had to participate in a deploy in the last 8 months unless something's going wrong, which was not the case when, in our old world where I had to spin up an AWS instance, I had to put a CNAME in, I had to do this, I had to do that, I had to do that. These days, developers can write their application and get it out in a matter of minutes.
On-call is obviously something which, as an operations team, is something we need to think about and need to care about. And Rig has really helped us change how we approach on-call. We don't want heroes. We also don't want it to be a stressful event. We want on-call pretty much to be a non-event. The phone call I mentioned earlier was the first time I was called out of hours in 4 weeks of on-call. So it seems we're heading in the right direction. And on top of that, by having the standardization, it makes it easier for us to have other teams go on call as well. Previously, SRE was the only team on call. We're in the process of rolling this out across tech, and now have a number of other teams helping us out with that process. And there's been a bunch of other things which have happened as a result, which we did not predict when we started down this process. Some of which is, as the developers see an alert, they'll go, why is this alert firing? This can wait till the morning. And because they have that contextual knowledge, they've helped us refine our alerts such that we don't get woken up in the night at all. So yeah, anyway, we're still working on refining our on-call process, and we'll be publishing a blog post on our tech blog soon. So
for social people, BuzzFeed EXP is actually a handle on Twitter, which every week one person from the tech family takes it over and just tweets whatever they want. It's up to them. It's about individual personalities. And this week, it happens to be me. We're probably going to try and take a selfie after this and post on BuzzFeed EXP. If you're not following it, you should be. Tech.buzzfeed.com is our tech blog, where we write some cool stuff. And finally, but not the least, those are our Twitter handles. I'm Shrikola. It's like, Ricola with an S. And if you want to see a lot of food pictures, go there. It wasn't Andy. He loves taking photographs. He was actually a professional photographer, photographing race cars.
Yeah.
Yeah, so, definitely, if it fancies you, give us a follow. And that brings us to the end of it.
Well, thank you all very much for your time this evening.